Hi, Assalamualaikum. My name is Nursyasya Qistina, Binti Mohamad Zailani. Today I'm gonna talk about introduction of correlation. First thing first is in the statistics, correlation or discrepancy is any statistical relation, whether casual or not, between two random variable or bivariate data. Although in the broader sense, correlation may indicate any type of association. In statistics, it's usually refer to the degree to which a pair of variables are linearly related. Correlation is a statistical technique for determining the relationship between two variables, where correlation means relationship between two things called variables. In statistics, it really means a linear relationship. They increase or decrease together in a straight line pattern. The two variables that I said before is when increased together, it's referred to positive correlation. When one increase, then one increase while the other decrease is negative correlation, or when it's have no pattern at all, it's no correlation.
Assalamualaikum. My name is Nurhanisah, and now I would like to talk about our objective. There are four objectives. The first one is variable, independent, and dependent variables. The second one is the features, usage, and interpretation of scatter plot. The third one is the concept and the properties of correlation. And the last one is calculation of Pearson's and Spearman's correlation with interpretations. My name is Nurhanisah, and today I will explain what is scatter diagram. Scatter diagram is a simple and attractive method of measuring correlation by diagrammally representing bivariate distribution for determination of the nature of the correlation between variables is also known as scatter diagram method. And this method gives the investigator or analyst a visual idea of the nature of the association between of these two variables. It is the simplest method of studying the relationship between two variables, as there is no need to calculate any numerical values. Moreover, in scatter diagram, one variable is plotted on the horizontal axis and the other one is plotted on the vertical axis. The pattern of their intersecting point can be graphically shown on the relationship patterns. Now, I would like to explain how to draw a scatter diagram. There are two ways to draw a scatter diagram. For the first one is plot the value of the given variables, say x and y, along the x-axis and y-axis respectively. And then the second ways to draw a scatter diagram is show the plot value on the graph by dots, and each of these dots represent a pair of value. Now, interpretation of scatter diagram. Based on this slide, there are 5 types of scatter diagram. The first one is perfect positive correlation, and the second one is perfect negative correlation, and then perfect correlation, negative correlation, and no correlation.
Okay, next we go to when to use scatter plots. For the first one is before calculation. Always plot data before computing Pearson or Spearman correlation. Why? Because a graph helps you to see the pattern or lack of it. Next is for exploratory analysis, to identify potential relationship or anomaly. Next for exploratory analysis, to identify potential relationship or anomalies. Because plots help you spot interesting trends or viewpoint anomalies in the data. The last one is to communicate finding. Visual make trend easier to understand than raw number, because graphs are easier to understand than a table of number. Okay, next we go to common pitfall. Correlation is not the same as causation. Just because two variables trend together doesn't mean one causes the other. Example, when ice cream sales go up, drowning deaths also go up. But ice cream doesn't cause drowning. Hot weather makes people both eat ice cream and swim more. Next is outliers distort result. A single extreme point can skew the perceived relationship. Example, if most students score 60 to 80 on a test, but one one gets 0 or hundreds. It can change the average or correlation a lot. Next, the last one is scale manipulation. When changing axis scale can make trends appear stronger or weaker than they are. Example, a graph can be made to look like there's a big trend when there isn't, just by zooming in or zooming out. Okay, conclusion is two things moving together doesn't always mean one caused the other. Watch out for weird data points and tricky graphs. They can give the wrong idea.
Next, present correlation coefficient. We use the present correlation coefficient to see the extent to which two quantitative variables have a linear relationship, meaning that if one changes, the another also changes in a consistent direction. The value range from -1 to +1. If it is positive, it means that both increase equally. If it is negative, one increase and one decrease. But if the value is close to 0, the relationship may be weak or not linear at all. We can also tell whether the data follow a straight line or regression line. If the data points are close to the line, it means that the linear correlation is strong. This is formula the present correlation coefficient. In this formula, R represents the present correlation coefficient, which indicates the strength and direction of the linear relationship between two variables. N refers to the number of data pairs. X is the value of the first variable, while Y is the value of the second variable. Sigma xy represents the sum of the product of each pair of X and Y value. Sigma x is the total sum of X value. Sigma y is the total sum of Y value. Sigma x squared refers to the sum of the square of all X value. Present is appropriate when the data comes from a random sample or at least represent the population. Both variables must be continuous scalar, such as temperature or Y. In addition, we need to make sure that the relationship between the two variables is linear and normally distributed. If it is not normal or there are strong outliers, it is better to use Spinner correlation. Lastly, each pair of X and Y data must be independent, meaning not repeated data from the same subject.
On this slide, we're looking at an example of how to calculate person product moment correlation, which measure the strength of a linear relationship between two continuous variables. In this case, we're comparing study hours and exam hours for each student. The table shows how many hours each student studied and the score they receive on the exam. To calculate the correlation, we first find several values: the total of studies hours and all exam scores, the square of each individual values for both study hours and exam scores, the product of each pair of study hours and exam score. After calculating this, we apply the Pearson correlation formula. This formula basically compares how much the two variables increase or decrease together. When we plug in the values from the table, we find that the correlation coefficient is approximately 0.997. This number is very close to 1, which tells us that there is a very strong possibility correlation between how much a student studies and how well their scores on the exam. In simple terms, the more you study, the higher exam score is likely to be, at least in this data set. In conclusion, Pearson correlation coefficient successfully shows that there is a strong and positive association between study times and exam scores in this sample. This method is useful for analyzing linear relationship between two continuous variables,
that the necessary assumptions are met. However, it is important to remember correlation does not imply causation. Just because these variables move together doesn't mean that studying more directly causes higher score. There could be other factors involved. That said, this strong correlation does suggest that study hours could be a helpful indicator when predicting exam performance.